Now we're going to look at the sum of a finite geometric sequence. With a geometric sequence, you do not need to know your a sub n term. You do need to know your n, and you do need to know your first term. So if you look here, you've got your sigma notation, and from the sigma notation, it says take your first term, and in the numerator, multiply it by 1 minus r raised to the n power, and that's all divided by 1 minus r. Let's look at a few examples here, or an example, I should say. And if we first start by finding our r, you find r by taking your following term and divide it by the previous term. So if I take 45 and I divide it by 15, that gives me an r of 3. My first term here, my a sub 1, is 5. So if I write my a sub n, my explicit formula says my first term, which is 5, times my r, which is 3, raised to the power of n minus 1. Now, my a sub n, so that I can find my a sub n is 98,415. We're going to make that equal to 5 times 3 to the n minus 1 power. Now notice this is an exponential equation, and in order for me to solve this exponentially, I need to get the 3 to the n minus 1 by itself. So we're going to divide both sides here by 5. This equals 3 to the n minus 1 power, and 98,415 divided by 5 is 19,683. Now, we have to remember, how do I get rid of, or how do I drop down that exponent? If you remember how to undo, or our inverse operation, in order for me to undo an exponential, I need to do a logarithmic, or take the log of both sides. If you take the log of both sides, I'm going to end up with log of 1,900 or 19,683. And that's going to be equal to the log of 3 raised to the n minus 1 power. Now, our properties, when we were in our logarithms, our properties of logs say that when you have an exponent and it's in log form, you can pull that out as a multiplier. So that n minus 1 is going to be multiplied times log of 3. That's going to equal log of 19,683. And then divide both sides by log of 3. So that these cancel over here. And the log of 19,683 divided by log of 3 is going to give you 9, and that's equal to your n minus 1. And when you add 1 to both sides, n is going to come out to be 10. All right, so in sigma notation, it looks like this, where you have k equals 1, and then you'd have your 5 times 3 to the k minus 1 power up to 10. All right, so if we look at the formula says you take your a sub 1, which is our 5, multiply that times 1 minus r, and r was 3, to the power of n, and that was 10, all over 1 minus 3. Okay, so this comes out to be 5 times 1 minus 3 to the power of 10, all over negative 2. Typing this in your calculator, make sure that you use your parentheses, and in the numerator, if you type it in exactly how you see it here, you need an extra set of parentheses, and that sum is going to come out to be 100 647,620. Now you can check this in your calculator just like you could with arithmetic sequences. So you can go back to how you had written that down with the second stat and so on and check that, and it should come out to be 147,620. Okay, now I want you to go ahead and pause the video, try the problem that I have at the bottom of the page for you, and when you're done, unpause so you can come back and see if you've done your work correctly. Okay, this concludes finding the sum of a geometric sequence.